let's talk about a topic we, of course, are fairly familiar with, which is refactoring. We've heard about refactoring, we've done refactoring, but what I want to talk about today is how do we really approach refactoring? What I'm hoping is you can walk away with a few different things that would help you to approach this maybe a little bit more differently or a little bit more intently, and then be able to do a better job at refactoring. When it comes to refactoring, what is really refactoring? Refactoring is, here's what Martin Fowler defined it. I'm paraphrasing his words. He said refactoring is the art of improving the internals of a code, design of a code, without changing its external behavior. I think that's what also gets us into trouble with the boss, right? Because the boss says, let me understand this. You're going to take the time to refactor, and when you're done, the code is not going to do anything different. Tell us why we should pay you to do this. So we need to be able to understand why we want to refactor. He says it's the art of improving the internal design of a piece of code without changing its external behavior. But notice he also very carefully chose the words. He didn't say it's the engineering of. No, he didn't say that. He didn't say it's the science of. No, he said it's an art of. The reason it's an art of is you got to improvise. You have to consider the different things and evaluate it. And it involves a bit of opinions you bring into it rather than simply being an engineering approach. But the question is, how do we really approach refactoring? I'll talk about what I will not talk about in this talk first. I'm not going to talk about the exact refactoring technical things you would do. Like, for example, you can do extract method refactoring. You can do this, you can do that. The reason I won't talk about it is twofold. Number one, there are a lot of amazing books and articles and talks on exactly that, and they've done a really good job than I can here. Secondly, the way I am wired is I never ever try to remember a laundry list of things that I can do. I don't say, here's a list of techniques, let's follow from them. That's not the way I work. That's not the way I think. And so instead, I will go to something more fundamental. How do we approach refactoring? Now, when it comes to refactoring, refactoring honestly liberates us, because when I'm writing code, I don't have to be under pressure to do it in a perfect way, not because I cannot attain perfection, it's because I don't know what perfection is in a certain context. And as a result, if you really try to make things really perfect, you may actually end up making things actually worse in the long run. So for that reason, I would say refactoring gives us this beautiful opportunity where we can create something and come back and we can improve on it. So for that reason, I'm a big fan of this mantra that I follow, which is make it work, make it better real soon. And when I say real soon, I'm not talking about 7 months from now or even 7 days from now. So one of the tenets of test-driven development is this cycle of red-green refactor. So you have a failing test, you write minimally code to make it pass, and then you come back and refactor it. And it's impossible to get it right on the first write. So you want to write something and you want to run it, see if it really meets the expectations, but before you move on, immediately refactor it, make it better. So make it work, make it better real soon is generally a good practice to follow. But also, at some point, we need to become very honest with ourselves, because if we don't be honest, then we turn into somebody else over time. So it's perfectly okay to be proud about what we do. We don't have to clutter what we do. If you ask me, what do you do? I'll be honest about it. I'm a programmer. That's what I am. I love programming. And what do I do every day? I write code because I'm a programmer and I solve problems by writing code, by solving problems. So it's okay to be a programmer. I was talking to a person recently, and I asked him how things went, and he said, well, I've refactored this code. I said, you refactored the code, tell me what you did. And he explained what he did. And I looked at him and said, looks like you fixed a bug. And he said, well, yeah, I fixed a bug. Well, then why did you say you refactored it instead of saying you fixed the bug? He said, because it feels better to say that I refactored the code, right? I mean, this is exactly what you see people, right? You go to them and say, what do? I develop microservices. And you find out what they do. It's not microservices. Why you're telling you it feels good to say I'm a microservice. I mean, how can I sit in a table next to somebody and tell them I'm developing an enterprise application, right? Telling them I'm doing microservices makes me feel better. We lie every day. There's no reason to do it. If you're fixing a bug, you're fixing a bug. Say that you're fixing a bug. You're making an enhancement to the application. Say that you're enhancing application. Refactoring is different. Refactoring is where you take an existing code, you're not fixing bugs, you're not making enhancements, you are improving the design of the code. The question is, why? And the answer is extremely important but simple. Refactoring is done because it's got an economic impact. It's got an economic impact. You want to reduce the cost, the time, the effort it takes to modify the code in the future, so you are going to take the time to refactor it. You know, I travel a lot, so I'm in different places around the world every week, and I would go to a client site. I'm working with them during the day. In the evening, I would take my laptop or a book, and I would go to a restaurant, and I would start, sit down there, order some food, and I would start working until eventually the restaurant will come to me and say, we closed the restaurant an hour ago. We've been waiting politely. We have to kick you out. Can you leave? So now during the, over the dark streets, I'll be walking back to my hotel. And I always pause and think about it. In the busy evening, as I was going to the restaurant to have a meal, the streets are busy, people are having a lot of fun. I would look through the door, and there are restaurants and families and friends gathered and having a meal. And then now the streets are empty, I'm walking back to my hotel, and I would look through the same windows. And what I would notice is that the floors have been cleaned up, and the chairs are put on the top of the table. And in some restaurants, they have cleaned it out, they have set the table for the next day, and they are all ready. And I will always look at this and pause and say the restaurant has cleaned up everything, the barber shop has cleaned up their stuff, the store has cleaned up their stuff, and then I think about us, the programmers. We leave home and the cursor is still blinking on the debugging console, right? And the next morning you come in, you push the pizza away from last night, and you continue debugging from there, right? And I always say, what if we had that discipline where at the end of the day, we cleaned up our stuff, we did a reset, and we said, today is done, I'm going to start my work tomorrow. And as it turns out, you may say, gosh, we are not barbershop, we are not restaurants, we do engineering. Well, guess what? I have seen engineers build buildings, and the bad ones leave a mess. The good ones clean up at the end of the day, so you can actually safely walk without a nail protruding in the bottom of your shoes, and so we can be professionals as well. Well, refactoring is an opportunity to kind of do that resetting and think about it. Well, good old Frederick Brooks once said, he said, go ahead and build a software system, and when you're done building it, throw it away and start over. Now you have a chance of building a relevant system. Now try telling that to the boss, by the way. You go to the boss and say, do you think Frederick Brooks was a great software developer? And the boss says, I've read about it. Well, guess what Frederick Brooks said? He said, build the software, don't deploy, but delete it, right? This is the best way to get escorted away from the building, right? Because you cannot delete a system practically. Does it mean Frederick Brooks was wrong to tell us to delete? Well, no, he was absolutely correct. But what if you do a micro deletion rather than a macro deletion? You write that little code, but refactor it before you go forward. That gives an opportunity for us to keep improving what we do. That's another area of improvement, what we can do as well. So with that said, let's talk about how we can approach this. So we talked about what's refactoring, and I'm going to say it's a genuine desire to improve the quality and the design of the code. But why? The simple reason is you cannot be agile if your code sucks. That's the simple nature, right? So you are sitting in this meeting, everybody is talking to each other, and now they are talking about having to make a change to the XYZ module. And immediately you perk up and say, excuse me, did you say you want to make a change to the XYZ module? And they're like, we want to change the XYZ module. Like, no, don't even bother touching it. Because you remember the last time they touched the XYZ module, you couldn't go home for the weekend. You had to be at work trying to fix this mess. And now you tell them, no, we can do anything you want to, but don't touch that module, right? And you cannot be agile if your code really sucks. If you want to be agile, if you want to respond to change, you need to be sitting on a good quality code. But of course, we know we cannot create good quality code in the beginning, not because we are incapable, because we have other things to really do. What is programming? I mean, have you ever seen anybody do this? You give them a problem, and they say, no problem. And then they sit there, and then they just type away, and then they say, I'm done, and they walk away. And you tell them, have you tested it? Like, I don't need to test it. I wrote it, it's going to work. And they walk away. Has that ever happened to you? No, right? How do you program normally? You start writing code, you bang on the keyboard, you scream a little bit, you Google search a bit, and you're thinking about it. Is that the way it works? Right? That's the way it works, right? My wife always tells this. One day she said, Venkat, you are a very polite person. You don't use bad words at all in talking to people. And I said, yeah, that's I don't believe in saying bad words to people. And she said, no, but. And the but is always a scary thing that comes. And she said, but. And I said, but what? And she said, I work in my basement. And she said, occasionally I would come to the basement because I want to get something in the fridge. You don't even know that I came and left. And you will be coding. And the amount of filth that comes from your mouth when you're coding, I'm like, I'm sorry, dear, but that's called programming, right? So when you're writing code, you're a different person altogether because the code is what you're communicating with, not the person. But that's the whole point. When you're writing code, if the code is of not good quality, you cannot embrace change. It becomes really hard. So it's important to have the good quality code. That is absolutely essential. But you say, wait a minute though, but it takes time. But guess what? Anything useful in life takes time. We have to take the time to get better at what we do. That's just the nature of what we do. It takes time to do almost anything in life. So the first law of programming says lowering quality lengthens the development time. So if you really want to go slower, write poor quality code, because poor quality code will really make you go slower. But if you want to go faster, you have to really write better quality. One of the slogans I say is this: sometimes you have to slow down in order to gain speed. This is a bit ironic, right? So sometimes you have to slow down if you want to gain speed. Because if you don't slow down at the time you need to slow down, you may end up in a ditch. And this is not going to help you. So there are times you want to slow down so you can gain speed as you move along. That becomes very necessary. So having said this though, so the question we want to ask here is, how can we really get better at it? So we want to refactor in order for us to be able to be cost effective in making the change. And so we want to be able to effect change and embrace change. That's the reason we want to continue to refactor. That's the real purpose of refactoring. So one of the beautiful comment by Abelson and Sussman says, programs must be written for people to read and only incidentally for machines to execute. What a beautiful thought, isn't it? You want to write the code for fellow humans to understand more than a machine to execute, and we need to really keep that in mind. So I'll tell you one more reason why you want to improve the quality of code that you are writing. And the one more reason that you want to improve the quality of code is how we tell our colleagues how we feel about them. So what do you tell your colleagues? Do you tell them, I love you all, or do you tell them, I hate you all? The code is how you communicate that, right? So at the end of the day, you want to really keep one thing in mind. We talked about economics, sure, but coding is an act of empathy. So you want to really think about that. Think about the person that is going to look at the code, right? What do we do in a civilized world? You're walking through the door, and that door, you're going to push that door to open it. But what do you do as soon as you push the door and step away? Ever so gently, you hold it just for a moment, don't you? Why? Because you don't want the door to swing and hit the person behind you. That person behind you may be a complete stranger, but you have that empathy deep down in your mind. And as you push the door, you hold it just for a minute. Sometimes you glance to see if there's anybody, and then you walk away. But the key is this: every time you push the code, there is somebody pulling it on the other side. You don't want it to hit them on the face. So always think of the person who is going to read your code. That becomes absolutely necessary for us to think about it. So given this, of course, we want to think about the reader of the code. And we need to evolve and incrementally develop it. So a code that is hard to understand is worse than the code that you don't even have access to or is lost. So you want to be able to modify this code and move forward. So you want to be able to evolve the code because we constantly change software. That's what we do. So like I said, make it work, make it better real soon. And refactoring reduces the risk and leads to lightweight, pragmatic design. So a refactoring gives us an opportunity to come back and evolve, to come back and change, to come back and improve, and that becomes very, very valuable. So as I said earlier, Martin Fowler talks about this as an art of improving the design of existing code, and it's a process of changing a software system, he says, in a way that it does not alter the external behavior of the code, yet improves the internal structure, and that's what we are trying to achieve in this case. So strike a balance. Do I need to refactor or not? Remember, it is taking you away time from other things you're going to do. So how do you know if you want to refactor a code or not? Let me first tell you this. Don't refactor a code because you didn't write it. That's one thing we need to be careful about, right? Sometimes the developers are like, I'm going to change this code. Why? I don't like it. Why don't you like it? Because I didn't write it. Well, sorry, you're not going to write every piece of code you have written. And sometimes you need to keep in mind, you are not the same you. You writing code 2 years ago, I hope, is very different from you writing code today, because you have learned and improved, isn't it? The other day I saw one developer who was so angry. He was complaining endlessly about a piece of code, until somebody pointed out the version control shows that he was the original author of the code, right? He's like, gosh, I don't even remember writing this code. So sometimes we get really angry at code. So don't refactor because you don't like what you're seeing. You got to be able to convince yourself and others why you want to change it. So consider the impact of the change you're going to make. Get a second opinion. Go to a colleague and say, hey, I'm going to refactor this code. What do you think? And 3 things can happen, right? He or she is going to tell you, yeah, go for it. That's a good idea. And what you're thinking is good, go for it. Or they may say, hey, I just was in a meeting. We're going to throw away that system in less than 2 months. Don't waste your time refactoring it. Or, oh, I just know that you're going to have a replacement for it, or we have an alternative already in work. Somebody else is building it. Don't spend time refactoring it. So don't do it without consulting. And don't do it alone. It's a great experience to pair with somebody and do the refactoring. Refactoring is hard. Well, yeah, like a lot of things in life is hard. Driving is hard. The first time I started driving, the entire city was scared that I was driving. So driving is really hard. Speaking in front of people is really hard. Socializing is hard and awkward for a lot of people. And so there's a lot of stuff that is hard for a lot of us. Now, of course, it depends on how we approach it. And so how can we approach this? As Roosevelt said, the only thing to fear is fear itself. So if you are fearful of doing something, Address that fear head on. Ask yourselves, why are you afraid to do it rather than trying to avoid doing it? So, don't fear what you're going to do, including refactoring. So, but why do we fear refactoring? These are genuine reasons, isn't it? The first reason, what if I break something that actually works? Is that a reasonable fear? Right? You're going to refactor a code, and you finish refactoring, and you say, I'm done refactoring, and they find 20 things that don't work anymore. The next time you say, I'm going to refactor, everybody comes to the defense, not to you, of the code, right? And they tell you, stop, please don't, and they don't want you to refactor. Is the change worse than the original solution? That can sometimes be a problem, right? I finished the change, I was like, isn't that awesome? Everybody's like, no, right? This is worse than what it was. Why would you do this? And we had been embarrassed, and it's easy to leave things alone. You know what? It's there. I didn't write it, but if I change it, then I become responsible. I don't want to take the responsibility. I'm going to leave it. So let's think about these things. What if I break something that actually worked? How do you think I can cure that fear? Have test cases, right? Run your test cases, make sure the code is working, modify the code, rerun your test cases. And you say, what is this thing called test case you keep talking about, right? Where do I buy that from? Which store do they sell it? Well, sometimes you're refactoring the code so you can write those damn tests in the first place, right? So my recommendation is, if you have automated tests, use them. If you don't have automated unit tests, look for automated integration tests. If you don't have automated integration tests, come up with at least some kind of a manual test that you can run and get the feedback and then modify the code. So the key here is not that you need to have a test. The key here is you need to have a feedback. That's the key. Somehow you need to know the before and after are still the same. If things are worse than the original code, how do you cure that fear? What if this is poorer than what it was? What can you do? What was that? What was that? Say it again? No, but what if this is worse than before? How do I know it's not? How do I cure that fear? Yeah. Go to a colleague and say, can you take a look at this? Can you review it? Can you pair up with me and work on it? But having another pair of eyes to look at it is a great feedback, right? So that can help. We hate being embarrassed. It's easy to leave things as it is. How do you deal with embarrassment? You know the answer for it, right? As programmers, we are shameless already. Right? Isn't that true? Anybody who wrote code, anybody who has ever written code, what did you do? You said, I want to learn programming. And people around you are like, really? Have you ever written a code? No, I'm going to write programming. And you come with this eagerness to write programming, right? And you write your first code. And when you say, I wrote the code, and the person next to you says, we wrote the code. Dude, did you ever compile this? And you're like, oh, I need to compile it. And you ran the compiler. What did it do? Literally, it spat on your face, right? It said, oh, and you're like, my gosh, what's that? And you take this and you drop it, and they say, that's your first compiler error. If you got embarrassed and insulted, the programming field would never have existed. The people who wrote the code removed the spit, and they wrote more code. And 10 years later, you write code, and what happens? It spits more. And you're like, bring it on, right? So that is what we are, right? Programmers are the bravest people on earth. We get scolded, spit on, every abusive word you can think of, the compiler throws at us, and we are like, still we go back and we work with it, right? And when it finally works, just for that 5 seconds, we get really excited before everything falls apart again. This is the beauty of what we do, right? Absolutely. So get over that. Okay. So let's consider some principles that can help us to refactor. I call this a zeroth principle. So what's the zeroth principle? Rely on automated test. Ideally, you want to have unit test. If you cannot have unit test, rely on functional test or integration test. If you cannot have that, look for some kind of a manual test. What you want is a feedback loop. Here's what it did before, here's what it's doing. But here's one other thing. Once you run your test, whatever form that test is, break your code and rerun those test cases, manual or automated. Make sure the test shows you that your code is broken. Why? Because you don't want to have a false positive. Oh my gosh, everything is great, but the code was not even testing the code you're going to refactor. Once you know it actually has the eyes on the code, put that back together, make sure the test is passing again, manual or automated, and then start refactoring right after that. So the first thing is never refactor code that is without any kind of a feedback mechanism. That's the first thing. Second, so what do you look for? Surprisingly, a good advice can come from really different places, but for me, one of them is a fantastic book that I read years ago. It's a very old book, but it's a book on writing good English. And this is a fantastic book on how do you write nonfiction. And this book talks about when you're writing English, you're writing maybe an article, book, a blog post, doesn't matter, anything that is not a fiction. What do you focus on? The author of this book, William Zinsser, distills down to 4 principles. As I was reading this book, I said to myself, oh my goodness, these are not just principles for writing good English, these are for writing code as well. He says, keep your writing really simple. The second thing he says is focus on clarity. Now, simplicity and clarity, right? So if you think about clarity, when we look at a code, if there's no good flow in the code, it's very difficult to understand the code. So same thing, but clarity is important. Brevity, he says shorter chapters are better than longer chapters, shorter sentences are better than longer sentences. Same thing we talk about, right? Shorter functions are better than longer functions, shorter classes better than longer classes, shorter application code is better than longer application code. And then he talks about humanity as well, and you want to consider humanity when you write English. Well, we talked about this earlier, how humanity and empathy are really important for what we do. The next thing I would tell is, the first principle I call it is reduce code. And so don't write code that is really not necessary. I'm a big fan of this minimalism. Do you need it? Do you need it? Do you need it? We call this the Yagni principle. You aren't going to need it. So if you're writing some code and you don't really know you need it, don't write the code. I have a silly metaphor, if you will. And the metaphor I'm going to say here is, I'm going to say code is like people on a crowded train. So if you think about it, right, when you have a crowded train filled with people, what happens? The people in the train cannot come out and you cannot go in. And if the train is overcrowded, code is like that. You have a lot of code, it becomes harder to write code. But if you have a minimum amount of code, you can much easily write code. So you want to really reduce code as much as you can. That's absolutely important. So don't write any code that is not needed. And code you don't write hands down, the code you did not write has the fewest bugs in it, right? So if you want to remove bug, remove code. That's the easiest way to do it, right? So you don't need to write code. And it takes courage not to write code. I remember this experience, I would never forget. I say courage because of this. I came from an international trip, and I was starving, like I was hungry. And I went to a restaurant, and I sat down, and the waiter, nice guy, came and said, what would you like to have? And I said, I want to have this, 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 and this. And in a very straight face, he looked at me and said, I'm sorry, but who else is joining you for lunch? And I said, what do you mean? I'm here alone. And he said, all of that is for you. And he kind of sized me. And I said, yeah, I'm hungry, I want all of that. And he said, I won't serve you that much food. I'm like, excuse me? I am here to order food and you won't serve it to me? And he said, how about I give you a deal? I said, I like deals, what do you have? He said, you tell me 2 things you want, I will serve you that. If you finish those 2 things and you still want food, I'll give you the other food with no charge to you. I said, I love this deal, let's do that. And I ordered 2 items out of the 4 items I wanted to get. He served me the 2 items, I managed to finish half of that. And he came and said, so, do you want me to bring more food with no cost to you? I said, no, thanks for feeding sense into my mind. That's the courage you want. What if you can tell your product owners and your business analyst, I am not going to write that code because I don't understand the requirements yet, right? That's courage. Instead, hey, what are you doing? I'm busy right now. What are you doing? I don't know, but I got to get this done, right? So we tend to really focus on writing code. Instead, we should focus on solving problems, not on writing code. That's very essential. So the first principle is reduce code as much as you can. And here's a beautiful quote. Perfection is achieved not when there is nothing left to add, but when there is nothing left to remove. So refactoring is about removing stuff. You don't want, I'm working on a book right now, and I went to a person who is going to give a feedback, and it's a humbling experience, I'll tell you this. I've written many books, but it doesn't matter. It's a humbling experience. I wrote the chapter 2 weeks ago, went to him last week, and I gave him the chapter and said, review it. And his review was, I'm going to take this chapter and start removing things. And I worked with this review, and I gave it back to him on Monday, and again we went through this, and he said, let's remove more. And so we've been removing things from the chapter, not adding things to the chapter. But every time we wrote something, the chapter is becoming laser focused, right? It is getting directly to what we want to talk about. That's exactly what you want to do in your code. Ask, what can I remove, not what can I add? So removing things really gives you the focus and removes the clutter, and you're able to focus on it. You want to definitely do that as well. The second principle, avoid clever code, keep it simple. Make it clear, not clever. Raise your hand if you have ever written clever code in your life. Oh, come on. No? You don't write code at all then, right? Let me try this again. Raise your hand if you have ever written clever code in your life. Really? The other people are just stubborn. They won't raise the hand, right? Maybe they're never programmed in their life. Everybody writes clever code, isn't it? Why do you write clever code? Honestly, why do you write clever code? Because it feels good, right? It feels good. You take a code, you turn to your colleague, and your colleague says, yeah, that looks simple. You feel let down. You're like, let me come back tomorrow. And the next day you go back and say, here you go. And your colleague is like, I'm trying to figure it out. You're like, yeah. Right? I mean, this is why I recommend that you hire the interns. Because the interns are awesome. When they come and work in your company, don't send them alone. Go with them to campus and hear what they are saying. And they will tell their colleagues, right? Hey, what did you do? I interned with this company. Really? How did it go? I mean, these people are genius. I didn't understand anything they are doing, right? We love writing clever code. And you go to mom and say, Mom, I wrote code yesterday and nobody understood it. Child, I always knew you're smart one among the group, right? We have this misguided notion, but it's important to go in the opposite direction. We want to write clear code, not clever code. And nowadays, when I write code, my little brain says, oh, that's clever. I delete it right away. And I start over, I want to write clear code. Clear code communicates much easily, easy to understand, less error prone, easy to maintain as well. Third principle, make it small, make it cohesive. Cohesion is a very important principle we want to keep in mind. So you want a piece of code to be narrow and focused and do one thing and one thing really well. That's cohesion, and you want to make the code really small. Why? Because a code that is cohesive changes less frequently. A code that is not cohesive changes more frequently. Not only that, it's more expensive to change it as well, because when you go to make the change to the code, there are parts in the code that are irrelevant, and it's incredibly hard to change it. I'll give you an example of cohesion. When I was a kid, My mom and dad tried really hard to teach me cohesion as a child. I would come back from school and I'm eager to go out and play on the streets. Who want to be in the house being lectured? So I would come in and I would throw things into a cupboard and run away. Because throwing things into a cupboard is the fastest way to put things in a cupboard, right? Everybody knows that. And if you ever open the cupboard, you would see everything in there. My lunchbox, my socks, my clothes, my books, my play items. Think of it. Sometimes even a fork and a knife would be there. But it was optimized to put things in. The minute I need a sock, it's a different story. You found a blue sock, you cannot find the other blue sock. And for 10 minutes, you are trying to find it. And you may wonder, if you don't find things, what do you do? This is why you are part of a bigger family, right? You got many brothers and sisters, you can use their help. I want one more sock which is blue in color. You have an army of people searching for it. This doesn't work really well, but that's the way I kept everything in one place, throw everything together. And mom and dad said, you don't do things like this. You keep your books over there, you keep your socks over here. Like, why would you do that? This is fast, right? To throw things in. I know you're thinking, my gosh, this sounds really terrible. How did this guy turn out to be the way he is? I got married, and that took care of everything for me after that, right? Nowadays, there's discipline, right? Things belong here. Don't put things here. Mom doesn't live here. Yes, ma'am. And you put things in the proper place, right? So the point really is, you keep things like things are together, unlike things are apart. That's exactly what cohesion really is. That's basically what we're doing. So avoid long functions. And you want to really make sure that functions have a single responsibility. If it doesn't belong here, don't put it there. And when we say avoid long functions, we are not talking about the length of the function, but the number of abstractions in the function. That's what you're really focused on in making it better. The fourth principle is to keep it dry. The dry principle says every piece of knowledge in a system must have a single unambiguous authoritative representation. So you want to ask the question, is this the right place for that particular knowledge, for that particular logic, or am I duplicating it in multiple places? And you want to really, as much as possible, reduce that duplication in your code. That is another thing you look for in refactoring, is to remove the duplication. And of course, eliminate the dependencies. And no, don't just strive to reduce dependency, eliminate it where you are able to do so. So if you don't need a particular dependency, you want to get rid of it, because the dependencies actually make it harder to test your system. So if you are able to move around your dependencies, then that's worth doing so, because that reduces your complexity as well. So eliminate dependencies where you are able to. Make comments redundant and remove them. I cannot emphasize this enough. Some people have this habit of commenting every 3 lines of code. Have you ever seen that? Right? Comment, comment, comment. And why do people write really, really bad comment? And the reason for that, I would say, is maybe they had really bad teachers. And the teachers tell them, you need to write comment when you're writing code. And you say, but teacher, professor, I write good code. I'll give you a F. Okay, I'm going to comment from now on, right? So we're taught very poorly to write comment every few lines of code we are writing. Now, this is something we should be very careful about. Have you ever seen this before? You're reading a comment, you're reading a code, and the comment says one thing, and the code does something else. Has it ever happened? And now you're like, which one do I trust, right? And that's very confusing. This is even worse. I joined a company, and I worked with them for about a year. And most people who wrote the code had quit. They are all gone. But I had the code with a lot of comments in it. And a year later, the company said, we have an event and we have invited a lot of people who used to work with us. So I go into a room and everybody is socializing. And all the comments, by the way, would have the initial of the person who wrote the comment, right? So it's like the first letter of the first name, first letter of the last name. And I walked up to this guy and I said, hey, are you LK? And he was like so happy. He said, I am LK. Have you met before? I said, no, but I've read your comments, right? Because I could hear his voice in the comment. That's kind of dangerous, right? Because he's speaking, I'm like, I know that comment, right? I know that voice in people. That's when you know people have gone overboard with this. So you probably have seen this as well, right? So you probably have seen something like this. You are looking at a piece of code, and what did the programmer do? The programmer has a function where there is, code that is sitting right there, lines of code as you can see, there is code right here. So you see this code being repeated over and over and over like that in a long function, right? You see this. But what you notice is right about here, this does blah, right? And then a few lines later, you have this does, another thing, blah too. And then a few lines later, have you ever seen code like this, right? A few lines of code, a comment, a few lines of code, a comment, yes? You know what this means? It means the person who wrote this code is a bad programmer, but not a bad human being. Deep down, they thought about the person who may read the code eventually. And a guilt kicks in. And they said, let me just leave a comment. Okay, it doesn't feel that bad anymore, right? So this is a good person, a bad programmer. That's what this is. But what do you do? My recommendation is this. And that is, first of all, the comment why and not what. That's the very first thing. Comment why, not what. Why does this code exist? Why are you solving this problem like this? The why is what I want to know. The what is clear looking at the code, especially if it's written properly, right? So comment why, not what. Second, somebody looked at the piece of code and said, my gosh, this code is hard to understand. Write some comment. Whoa, time out. That's another rule I want to follow. Do not comment. So do not comment on bad code. Instead, refactor it. So a bad code deserves refactoring. It doesn't deserve commenting. And I was working for a company out in the Netherlands, and I had written a piece of code. And as a consultant, I keep moving around, and I went for another opportunity. I came back about 3 weeks later, and the team leader said, hey, Venkat, I need to show you some code that I worked on. And I said, yeah, what is it? And he opens a source code and he shows me, I was looking at this code, and this code was doing a few lines of code, then it had a for loop, and then had an if statement inside of that. And I read this, it took me about 10 minutes to learn the code. Once I understood what the code was doing, I went above the for loop, and I say // this for loop does this, and I wrote a comment. And I'm like, okay. And then he said, as soon as I wrote that comment, because I couldn't understand that code, I remembered you really don't like comments. You say that in your book. I read your book. You say don't write comments like this. So guess what I did? I turned that comment into a function name, and I called that function right there and took this code and moved into the new function. What do you think? And I said, I love this for 2 reasons. He said, really, what are the 2 reasons? The first reason is, it absolutely blows my mind. I'm happy that somebody actually read my book. And the second thing I'm really happy for is, do you know who wrote the code you just refactored? I don't know who wrote this code. I saw this and I refactored it. I said, I'm the one who wrote the code. He said, oh my gosh, I wouldn't have told this to you had I known you wrote this code. I said, no, that's the whole point, right? We have to keep improving on what we find. I'm not going to be perfect in writing the code, but you did the right thing, is to refactor it rather than writing a comment on it. So that is something we need to do, is to continuously improve the code we are writing. That's very important. So make the code self-documented and write executable comments. A good test is worth 1,000 comments you can write. Tests are a great way to learn what the code is doing. I wrote the very first book, I think, on Java 8. The book was released the day Java 8 was released. Now, you may say, how can you release a book when a version is released on the same day? Are you that fast in typing, right? No, I started writing the book 2 years before Java 8 was released. And guess what was not there 2 years before Java 8 was released? There was no Java doc for Streams API and all that. And I'm honestly, every day I would go get the version, through the version control, I would download the source code and I read their unit test. I learned Java 8 functional programming by reading their unit test because that was my guiding force. It's a form of documentation. So you can rely on good test as a form of documentation. Self-documenting, self-expressive code can be really useful. The seventh principle is make sense in seconds. You want the code to be immediately clear when you read it. It's got to be intentional. It is not just the size, it is about conveying the intent very explicitly. That's extremely important. So when you look at, oh, by the way, programmers are very polite people, but you have to really hear what they say. You probably have heard somebody say this, right? They say this, let me figure out what this code is doing. Have you ever heard people say those words? What are they saying? They are simply saying this code sucks. Right? Because why do you have to figure out what it's doing? It should be evident when you look at it, right? It's not like, I call this software archaeology, right? You're looking, wonder what this is doing. And everybody expresses their opinion. I wonder what they wrote back in time, right? This is like walking through a cave. Well, does this mean that? No, I don't think it means it because they did something similar, but it meant something. Man, these people are thinking there's consistency in the code, right? What a concept. But that's the problem is that we don't know what the code is doing. It becomes software archaeology at that point. So no, you don't want to figure out what the code is doing. Make it absolutely clear what the code is doing. Make it intentional. So here is an example, if you will. If I ask you what this code is doing, you have to. Let's think about this for a minute, right? So here is a yardstick I would use to see. So do not make the reader, read through every single line of code to understand what the code is doing. So in other words, when you look at this code, what just happened? What is it doing? Oh, let me figure it out. This is a for loop. In the for loop, I'm doing an if. Oh, in the if, I'm using this. Oh, I see what you're doing now. Well, you told me to know what it is doing, I have to read every single line of code. That is a punishment for anybody reading this code, right? What you want to do is you want to convey this really well. So look at the code in the bottom right now. What does it say? For string, if file is invalid. What does if file is invalid say? If the file is valid or not. Hey, what does valid mean? Maybe that I know that from the domain. How do you know it's valid? Simple answer, I don't care. And that is a very important, what does I don't care mean in programming words? What was that? Come on, say it louder. Abstraction and one more, the E word. Bingo, right? We've been told this 1,000 times. What do we do when we write code? That's for others. Abstraction and encapsulation. What does that mean? I abstracted it out. What does this code say? If it's valid, how do you know it's valid? I don't care. That's encapsulation. That's none of my business. If you want to know it, go over there and find it, right? So but what is the benefit of the code in the bottom? Not that it's perfect, but it tells you what without forcing you to look at every single detail of the how. So in other words, you want to convey the what and delegate the how. Convey the what, delegate the how. Hey, what are you doing? Here you go. How are you doing it? Over there, not my business, right? So have you worked with people who write long functions? Raise your hand if you have. Okay, do you believe long functions are a good idea? Venkat, I love long functions. I go every day and make my functions longer. Raise your hand if you do. Anybody? No. Have you seen long functions at work? Just look around. Keep your hands up and look around, right? That's called cognitive dissonance, right? I got a good news for you, and I got a bad news for you. The good news You didn't write those functions. I mean, you just told me a few minutes ago, right? Bad news. The people who wrote those long functions are at work right now, making those functions longer, right? So, communication. You go to work on Monday. Don't say a word, just sit down and work. And your colleague, you know who I'm talking about, right? The one who writes long functions, comes to you and says, hey, how was your weekend? You could tell this to your colleague, right? My weekend was great. On Saturday, I went to the park. Sunday, I went to the movie. That's it. But don't say it. You say, oh, my weekend. At 7 o'clock on Saturday, I took the car out of the garage, drove for 2 kilometers, took a left turn, drove for 3 kilometers, took a right turn, drove for about 2 kilometers, started raining. It was cloudy. I could even smell the soil. And that's when I noticed that the road got slippery. So I had to make a U-turn. And I came back this way and took a left turn. Keep going like this for a while, as much as you can keep going, right? At some point, your colleague says, excuse me, have you gone mad? And you say, no, I thought I'll tell you how my weekend was, like the way you write code, right? That's not the way we communicate, right? What do? We communicate in knowledge chunks. How's your weekend? Great. On Saturday, I went to the movie. On Saturday, I went to the park. Sunday, I went to the movie. Really? Which park did you go to? I don't care about the movie, right? Oh, the park, the one by the main street. Oh, yeah, I've heard about it. Is it family friendly? Oh, yeah, I took all the kids. They had a great time. What kind of activities did they have? Notice what we are doing. We didn't give them all the details, right? What is that called? It's called SLAP. No, not physically. It stands for single level of abstraction. So, principle. We use the compose method pattern. So, instructions are at a single level of abstraction or detail. So this is how we communicate. Hey, how was your weekend? Went to the park on Saturday, went to the movie on Sunday. That's SLAP, that's compose method. Did I tell you which park? Did I tell you how I went there? Did I tell you that I took a train or a bus? Did I tell you what time I went? No. That's the level of abstraction, level of detail. Did I tell you what movie I went to? Where I went to? Who the actor was? No, went to a movie. That's the level of abstraction. Dive into the next level, delegate down, right? So that is the key. So tell me what, delegate the how, focus at a single level of abstraction that we can focus on. So, eighth principle, avoid primitive obsession. Primitive obsession is where we feel like we have to write the code at the lowest level possible. Use libraries, use methods that you can rely upon to build on your code rather than being at that low level of detail. So here's an example. Is spelling correct? Ironically, that function name itself is not spelled correctly. Look at the code. What is it doing? Everything. Is it mixing the what and the how? Absolutely, right? And besides it, what does the function tell you? It tells you, I need to do everything. I am the one who's going to tell you how to do it. Let's rethink about it. What if I do this? Is spelling correct says, I'm going to just get the file and see if the word is contained in it, and maybe I can work with that particular abstraction. So the point is, you want to rely upon and delegate to functions to do the job. Check in frequently and take small steps. How often do I commit code? Commit code as soon as a test passes. Let's be very honest about it. Have you ever done this? You have a code, you start changing it, you're making some changes, you change this file, change that file, change that file, change that file, and then you're like, I don't like this idea. I don't like this design. So I need to undo the change. But I've made a few other changes. So I'm going to undo this one change I'm going to make. Have you ever opened files, change it, put it back, undo, 10 minutes later? Did I forget one more file? Has it ever happened? Yeah, we all have done that, right? But here's the key thing. One of the key reasons why you want to commit frequently is the following. Commit frequently so you can reduce the cost of undo to near zero. That's one of the biggest reasons. It liberates you so you can innovate. You committed the code. I don't have it with me. It's safe. I change it. Oh, you know what? I don't like it. Blow it away. Get a copy from the version control, and off you move forward. The cost of undo is near zero. You don't fear making change when you can roll back to the previous state very easily. That's the reason for it. So you want to commit frequently and take very small steps. So check in frequently. The 10th principle, keep code at one level of abstraction. We talked about the compose method pattern. So don't try to write code that you can delegate to another function so it's easier to understand what the code is doing. So convey the what, like I said, is extremely important. So is this a refactoring opportunity? Should I refactor now? So make refactoring a regular activity every day. Do not do big bang refactoring. You want to incrementally refactor your code. So when not to refactor, sometimes the code is a complete mess. You may have to rewrite it. If it is, it may be too much of an effort to refactor your way to where you want to go. But again, consult with others around you to see if this is the right thing to do. And so when to refactor? Refactor before you fix a bug, or refactor after you fix a bug. Don't refactor while you're fixing a bug. Why is that? I'm fixing a bug. Oh, I think that can be better. I'm going to modify that function. Now you mixed the two changes into one, and you commit it. 3 weeks later, they're like, we don't want to fix that bug the way you did. We're going to roll back the change. What did you lose? The refactoring with it. Don't want to do that, right? You want the refactor to be separate from the bug fixing, separate from enhancements you make. So you want to be able to refactor before you enhance a feature, or after you do, never in the middle. Don't refactor in the middle of another refactoring. Be purposeful. What are you refactoring? I'm refactoring this database access class. Then why are you messing with that one right there? That's not related. Keep that refactoring separate. So keep those refactoring things separate as separate commits. So when it comes to this, we talked about how do you refactor? Take very small steps. Devise a sequence of steps you can take to refactor. Be continuous, not episodic. Take in these small steps. Be graceful in what you do. Aim for bite-sized, useful improvements. Here's a good step to do. Great. That works. Commit. Here's a next step to take. Good. That works. Test pass. Commit. Take this incremental step to refactor. Never refactor code that's not in a version control. So what that means is, I just finished refactoring. The test is working. I'm going to do the next refactoring. Is the change in the version control? Not yet. Then don't refactor. Commit that and refactor. Because you want to reduce the cost of change to zero, right? It gives the power to try ideas. Don't hesitate to throw out change. I was on a 16-hour flight. When I got into the flight, I said to myself, I'm going to write a feature. And I wrote the feature on this long flight. And by the end of the flight, I finished writing the feature. As I was going through immigration, I said to myself, I hate the code, every bit of it. I don't like the design. But guess what? It works. And I checked into the hotel, and right there in front of me is my computer. I took a deep breath and I said, there you go. Delete it. And it was so hard, right? Because your hands are going to delete, your mind is like, please don't. You spent 16 hours writing this. Delete it. And now it felt so liberating. It only took me about 4 more hours to write it now. Like, why? Because now I know the problem much better than I started out. I got a better idea on the design, and I rewrote it. And this is one of the things I always say. Be willing to delete and check in frequently. So what's the flow? Identify the code you want to refactor. Next step. Got test? Not really. Okay, write test and isolate if you need to. Okay, now we got some test. What should we do? Perform a small and yet useful improvement. Yeah, that works. That's a good change. Does your test pass? Ensure the tests are passing. Hey, the tests are passing, but I'm not done with the refactoring. What should I do? Yes, commit the code, because that's a good, useful step we took. Rinse and repeat, right? So go to the next step now and continue. So that's what I would call as the flow. So be purposeful, be deliberate, be incremental, be graceful. Take control of it so it doesn't take control of you. You need to be able to ride through this. And it's a skill. The first few times you do it, you find it awkward, find it a little hard. But the more you do and the more deliberate you are, the much better handle you have on this as well. That's all I have. Hope that was useful.